Well, g'day, Max here again. Welcome back to the shop. Welcome to 2024. So, just making a plug gauge here, and that's going to be so we can size our hexagon shaped hole that we can broach, or that we're going to broach in this aluminium hand wheel. So what I'm making here is a hexagonal plug gauge, and we'll use that when we broach the hexagonal hole in this hand wheel. So this is what the hand wheel fits on, and this part here is going to be a little bit unwieldy to jiggle around in the milling machine for a test fit, so hence the little plug gauge. So this is our setup in the rotary table here. So the parallels give us clearance underneath the hub of the wheel, so when the tool breaks through we don't start cutting into the rotary table, and we have a couple of shims in, and that takes the rock out of the hand wheel before we clamp it down. So as far as getting the hand wheel centralised on the rotary table, I've got this set. It's a Starrett set, 25R contact point set, and it has this really wide one down the bottom. It looks it's a slightly bigger version of that one there, and it's ideal for this sort of thing. So all I do is just concentrate on 4 areas. It's the same as when you're dialing in a 4-jaw chuck. So if we look around here, we're sort of hovering -5 to 0-ish. So we'll come round half a turn, and we're sort of hovering sort of -5 to 0-ish. Over here, we're sort of hovering around between 5 and 15, average out at 10. We'll come around the other side. Now this side has a bit of a hump in it there, so we're about 10, and we're about 10 just before the hump. So that's just averaged the whole thing out and makes it easy to do. Otherwise you're going to be chasing your tail, as these will not be round, they'll be egg shaped, whatever. So that was that. So this little elephant's foot contraption that I have on here, obviously it just unscrews. Now these are, being Starrett, it's made for Starrett dial indicators. My dial indicators are Mercer, made in England, and it does fit them. However, it does not fit my Mitutoyo indicators, as they have a slightly smaller thread on it. So, sort of useless information, but they're quite a good, you don't use them very often, but sometimes when you when you do, you do. Right, let's get set up and get our hole drilled. So just before we centralise the rotary table, I just want to give ourselves a bit of a flat area to work to, and also get rid of this drill divot here. Now this is what we did when we first looked at the job. We were looking at the roughness, and there's a bit of a hexagon outline around the hole, so we weren't sure if that was still like a sand core or something, and there was actually a hexagon hole in there, but not to be. So yeah, we need to clean this up, and making it flat there, when we go to broach, it gives the broach a flat area to start on. Okay, that'll give us some cleaner edges to work to now. So we'll get the tool set up and we'll drill it, then bore it, then broach it. So this is my preferred method of indicating the rotary table into the axis of the machine. Mag base just on the rotating on the chuck, and we're just indicating into the quill. And I find that's the most accurate way to do it, rather than indicating off the little hole in the rotary table and like something like a last word or something held in a chuck or in the quill. That's how I do it. Okay, we'll start off with a spot drill. The only reason I'm using my biggest one is because it gets little use, and more opportunities I use it, I use it. You know, sometimes it's too big for some things, so. So we'll poke this 15.5mm drill through prior to setting up the boring head. That's just in a Morse taper to R8 adapter. And we swapped over and put the old Tangent Engineering quill wheel back on the Bridgeport. As when you're drilling, it's way easier than these things. That's it, we're through. Okay, we'll get our boring head set up and we'll do a clean-up pass through the bore. Well, I had the GoPro running as a bit of a backup. It just conked out and got a bit hot, shut down. It's not even a hot day. What are we? 34 degrees, 94 in Fahrenheit. Still, it is summer. So we need to get a size here so we sort of know what's going on, where we are. So we're aiming for 17.1, 16.38. Okay, minus 16.38 gives us 0.72 to come off the diameter. Divide by 2, 0.36 millimeters. We've got to shift the head over. So what I can never remember with this boring head, because I don't use it very often, I can't remember if it reads off diameters or radius. So I'll just put a indicator on it so we know where I'm going. Point 1, point 2, point 3. 6 on there. Yeah, 0.36. We'll take it all in one hit. Okay. Right, bit of Wilksy special sauce. Away we go. Right, size check. That's not bad. Seems pretty parallel too, 17.1. So we can get our broaching tool set up now and start our cutting out the hexagon. So I've just remeasured that bore, 17.12 to 17.13, which is the same as our hexagonal gauge there. So I measured that with a telescopic gauge and micrometer. So we're bang on size there. Just a point to note there, when I did bore that hole, my target boring size I put at 17.1, and then we just took the cut through. If often it's what I try and do is just go that fraction amount under, and more often than not you can get that last little bit with a spring cut, but it wasn't necessary in this. It all worked out fine in this case. So this is the hexagonal hole that we have to broach. So the width of the flat is 9.884 millimeters, and our tool is 9.5 millimeters. So that'll give us a side shift off center of 0.192 millimeters. Either side of center. And of course, when our tool touches the bore of the hole, we're going to be at the correct depth. This is the tool that we're going to be using. It's a bit of Sutton M42 Cobalt. It's just a brand new blank I had sitting in the drawer, and it just goes into this holder, it's a blind holder, and we grip this in the collet chuck, shouldered, so it can't migrate up the collet chuck. I don't think it would anyway. I haven't really done anything to the end of it except the very last bit there. I've just touched up on a lapping disc that I have. That's set at a 5-degree angle. So we'll try it, we'll see how it goes. Okay, we need to get the front face of the tool indicated in parallel with the axis of the table of the machine. So we're just going to use a small grinding vise. Can't get the Allen key in the hole. Put some fur around it, son. Okay. So we'll get the indicator set up, and we can indicate this face here and should put our tool in the correct position. So that there will be good. So I'll lock the quill, put the brake on the quill, and it'll still have minimal movement, but it's not much at all. Thou out there, but if I go to the edge of the tool, half a thou, that's we can't lock the quill solid, or the Bridgeport will always have that little fleck of movement there. So, right. Okay, we've blued up the entrance to the hole with a Sharpie. So we'll just come down and plunge in gingerly till we hit the OD of the bore, hopefully. So I don't know how this tool's going to perform. We may have to pull it out and modify it, but we'll see how we go. Maybe a bit of lube, bit of WD. It'll play havoc with the Sharpie marker though, so. Looks to be all right, so we'll go a bit more. Okay, I'm going to stop there and I'm going to go round 180 degrees and then I can get a measurement. So it looks like we could have gone a fraction more, but I don't want to overcut it. So you can just see the line of Sharpie in the middle where we haven't cut it yet. And interesting to note, you can see the push off. From the top of the Sharpie to the top of the bore, we've got a straight line across. So we are getting a little bit of deflection in the tool, as to be expected. So if that becomes too much of a problem, what I'll do is I'll increase the angle on the back of the tool. So in fact, I might just do this other side and then I might just do that just to give it a sharper angle. Couple of thou to go till we're at the same point as we were on the other side. And final cut. Okay, so it looks like we're going to have to modify the tool a bit. You can see that gap in the middle slowly increasing. Now that's because at this stage I don't have any clearance on the on the front face of the tool, so it is causing a bit of push off. So what we might do, I've released the brake, so we'll have a look at this tool. What I'm going to do is increase this angle here, bring it right up, and I may have to grind some clearance in this area here, which I don't really want to do, but I think I'm going to have to do it. Let's just scallop a bit of this out so we're not getting the same rub off effect. What's happening as the tool goes in down into the bore, you get your initial push off, and that gets, the further the tool goes down the bore, that gets exaggerated further. So you end up with a slightly wedge-shaped bore, hence, yeah, you can see the narrowing effect when you look in there. So I'll pull this tool out, we'll rejig it, and we'll have another crack. Okay, if I can just interrupt the proceedings for a split second. While I'm over at the tool and cutter grinder, grinding the new tool or modifying the tool for our slotting head, which is in the next video, I'll release this video and the next video at the same time, so you don't have to wait. The postman came. So we've got a good one. Well, I'll rephrase it. We've got a boring one and we've got a really cool one. So let's just, I don't normally do this on camera, but let's just have a bit of a look, as I thought this cool one is a cool one. Let's come and have a look. So we'll get the boring one out of the way first. I've been watching this for a long time. This has been on eBay for the last couple of years, and it's a cross slide lead screw and nut for a JFMT lathe. So it's a spare one for my lathe. Now over here I cannot even buy a piece of bronze that big for the price that I paid for the whole thing. So I've been looking at it, it's been sitting there for a couple of years. I had it earmarked, and I went back the other week and had a look to see if it was still there, and it was, so I grabbed it. The only difference is, on mine, the nut is split for the adjuster, which wouldn't be a problem to do with this one. So, spare part for the JFMT. It could even be Mazak, this, I don't know. A lot of the parts are the same. JFMT was copied off Mazak. A few little minor differences, but it is a telescoping one for the tape turning attachment, so we'll put that one away. Now for the cool one. And Ian, I've got your file handles here too, mate, and they're about to be fitted to files. But check this out. This is from a guy named Gary over in America. You want to see this handwriting? How cool is that? So that'll go up in a special place on the wall. So in here we have one really cool, oh excuse me, file handle that Gary's made with his emblem on the back. It's come at the right time. All this has come, the timing could not have been better. And if you think you've seen file handles before, check this out. How's that? Even has a little raised section on the end of the ferrule. So I'll zoom in on this one. How's the workmanship that's gone into that? Very impressive. So yeah, a couple of ripper file handles, but check this out. I'll zoom you in on this one. How's that for a sexy looking scribing tool? Very impressive. So also in the box, we have a couple of Gary stickers. I've emailed him. I don't think he has a YouTube channel, but I'll investigate that. So we'll get a couple of these stickers up on the wall. And this cutie here. Mini Noga. And it's the one I like too, with the adjuster at the base. Actually, this might have both. Oh, it has. It's got fine adjust top and bottom. Wow. So, yeah, you've all seen Noga indicators, or most of us probably have. But, this will be a great addition. as I find using my standard ones very tight to get in a lot of places. So we're going to use this in the remaining part of the video. And to go with it, something I've never ever had a brand new one of before in my life. All mine are busted ass old ones. So that's a Shah's half hour graduation DTI, lever type DTI. So thank you very much, mate. This is truly appreciated. So we're about to use these ones here. No, that's really good. Never ever had a brand new lever DTI before in my life. So good stuff. Right, let's go again. So incidentally, I did forget to mention in the video where I was grinding the tool, that was a 150 grit, sold as a diamond CBN wheel. It's one of those cheapies from China's, and did an impressive job ripping the material off. And I did some carbide on it the other day, and it ripped it off, no worries. And then of course you have no problem smoothing out the edges with the diamond laps. So right, let's crack on. I'll just put a bit of WD on the tool. Oops, bumped the camera. And I had a friend over the other day. We were looking at the settings on my camera to hopefully stop that, stop it drifting from side to side like it has been doing quite often. So we'll see in the latter half of this video how the phone goes. Now let me have a look at that. Looking good. I'm going to have to reset the 0 on our depth, but we'll just go another couple of thou. Fraction more. Okay, I'm going to reset a 0 on our new indicator now. So this is so easy with the adjuster on the base. So reset 0. It's also got the adjuster at the top as well, so I've got the best of both worlds. So we'll run round, we'll rotate round now, and we'll do the other slots, and this is where we pull up at. Then we'll have a measure. So I'll index around another 60 degrees. So that'll bring us to 300 degrees on our dial. Lock off the table. And final cut, which is right there. Okay, we'll back her off rotate it round. Which is there. Okay, it's not cutting, but we're at the final depth. We did the other ones too. So we've got to keep going round till we match all these depths. Okay, 60 degrees there. I can feel it cutting on the bottom of that one, so it's pretty close to our original. It's probably our first one we did. So we're at depth. Rotate around another 60 degrees. Riveting stuff, isn't it? Coming up to depth now, and final, right there, final cut. Okay, so I'm going to rotate this around 180 degrees, and we're going to use this area and this area. I'll run the tool back through this area, then we'll get a definite size on our width, which will be about right there. So this tool should go down there without cutting, which it does. Okay, I'll get a measurement. See, our gauge wants to go in across these two flats here right at the beginning, and that would have been our first original cuts with the old tool. I'll get a definite measurement now, and then we'll know how far we have to go. 16.85 is where we are at. So that's 0.27 millimeters to come out, so we divide that by 2. Gives us 0.135 millimeters to come out. I'll write that down, 0.135 millimeters. Divide by 25.4, just over 5 thou. So we'll take another 5 thou out of them all, and then we'll remeasure. Okay, that's our full trip around. So we've got to be getting close. It wants to start. Let's get another measurement. We are 17.07. So that's 0.025 to come off in millimetres, or an imperial, divide by 25.4, close enough to a thou. So I think we'll take we'll take 1 thou off either side, and that should give us a bit of clearance. Okay, so I've just been around and taken 1 more thousandths of an inch off either side, and we're feeling now where we need to be with regards to the fit there. I might still do that side shift. It's like we're knocking on the door right here. Or I might just actually do that with a file. Let me have a measure. Okay, so I did a side shift on either side. It doesn't take anything off the width, it just nips off those corners. That was only a minor, it was 0.192 millimetres side shift. So that did the job. Our part slips in beautiful. Just feels like a couple of thou clearance, which is desirable. This is just what we want. Perfect. The finish inside came out really well. We'll get you a close-up of it. So we can quickly and easily check the play with our new toy, our new Noga and indicator, and we have 0.02 of an inch clearance, which is perfect. Right, so out it comes. Let's have a look at the bore. I'll give it a clean up first. So here's a shot of the bore. Came out very well. So I think we may have cured the problem with the camera drifting from side to side, hopefully. As I said, I had a friend come over yesterday and we went through some of the settings on the camera and turned a couple of things off on the camera. So we'll see how this video edits, and hopefully we've cured it. Oh well, that's that. Another job bites the dust, another one out the door. And we got to have a bit of a play with our mini Noga. That was I really enjoyed using that. It's going to be so handy to have. So, we better go and have a test fit on the real part. Hang on. Doesn't fit? No, just kidding. Fits perfect. Absolutely spot on. So this is part of the traverse mechanism off a old World War II anti-tank gun. Alright, we'll finish this one up here, so cheers, thanks for watching. Yeah, that was something a bit different that I don't really do a great deal of slotting. You know, it's a very time-consuming process. That sometimes you gotta do it. So, cheers. Hopefully, see you in the next video. Well, you'll see me. I won't see you.